Okay, welcome back. The first content video of our differential equations course, and this is going to be a very, very simple foundational introduction to the absolute basics. This is pretty much just all the basic facts that we're going to be using when we progress through this course. Um, and first, I guess it's appropriate to ask what a differential equation even is. Now, you could just look this up, and you'll get a differential equation is an algebraic relation involving the derivatives of one or more unknown functions with respect to one or more independent variables. Okay, but what does that mean? It's pretty simple. If you just see an equation with a differential, like dy dx equal to x sine x, you got yourself a differential equation. Like 4x plus y is not a differential equation. Okay, but y prime is equal to 4y prime 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 plus 2. Y prime is equal to sine 2x plus y cosine 2x. You got some differential equations. It's pretty simple. Um, Now, I purposely put in a few different ways to denote differential equations, and this is very important, and that's going to be our next slide, because these will come to different forms, and it's very important that you know and you can distinguish what's a differential equation, what exactly you're looking at. You can get it like y prime is equal to 2y prime plus x, or dy dt is equal to 14y plus 2t. It could be in terms of any variable, really, because variables are just arbitrary. Normally it's going to be y with respect to time. Um, and of course, sometimes you get the more esoteric, which I kind of like to do, where you denote the derivative with a dot. So y prime prime is equal to 14t plus 32y prime. It's pretty weird. I've only seen it once, and it's a lot of fun to do. Um, okay, so what is an ordinary differential equation? Because that term at least, has been brought up constantly in the introduction video. Excuse me. So it's pretty important. It's a derivative that only has one independent variable. So basically, all this means is that's only respect to one independent variable. So no partial derivatives. Okay, it's just gonna be like dy dt is equal to 4t, or y prime is equal to 4x plus y. We're not doing partial differential equations. This is a different course, different content. So like del q del t, or del, or maybe you're doing a partial derivative with respect to like x and y, or any combination of any partial derivative ever. Excuse me. This is not what we're interested in, except we will touch on this in the exact differential equation portion. But I'll let you know when we do that. Don't sweat it until then. It's very simple case. Outside of that, we're not touching any of these. So don't worry about it. We're only talking about some standard dy dt stuff. Alright, so what is order? Again, very simple. An order of a differential equation is the highest nth derivative of that equation. So, as you can see, don't get confused when you see this to like a squared. This isn't for an example, like this right here isn't ds dt squared. This is the second derivative. So, if this is the highest highest order derivative in the equation, then your equation is second derivative. Second order. Um, Third order here, obviously. Alright, it can go up to n. And then we also have linearity of differential equations, which is another very important thing. It could pretty much, for it to be linear, it has to be written in this form here. And I think it's easier to show you what's not linear and what is linear with just some examples. So here we have nonlinear. It's not linear because we have y multiplied by a derivative of y. You can't have, so see, since we're taking a derivative of y with respect to the variable, we can't have y multiplied or squared or cubed or in like some transcendental function. It has to be just y alone. Y could be multiplied by a constant. It could be multiplied by t, like for an example, 4y or negative 5 dy dt. Or here, t cubed multiplied by d squared y dt squared, or negative e to the t multiplied by dy dt. This is fine. You could have t in the argument of a transcendental function or a trigonometric function or whatever, like 5 times natural log of t is, we're still linear here. Now, if it was dt dy, it wouldn't be, because we're getting multiplied by t, the t is cubed, exponent of t, sine of t, ln of t, but since it's dy dt, it's fine, obviously. Okay, going over here, this is not linear, and it's because of the exponent here. Dy dt squared, it cannot be squared. So we have some more examples here to cap off this video, because I just want to do really short videos. I don't want some long-ass video where you're sifting through the content to find one specific thing. Just very simple, and this is some very simple stuff. So nonlinear. What makes this nonlinear? Ln of y. Okay. Another example. What makes this one nonlinear? Cosine of y. And also, what is the order of both of these? It's third order. Both of these are third order. What's wrong with this one? I actually underlined it and drew an arrow. It's cosine of y, but it's also, we're squaring dy dt, third derivative. Can't do that. You could put this dude in a cosine or a sine or a natural log. You could cube all you want with this guy. Can't do it with these. Or this. Now, linear examples. Okay, we can have the cosine and the t, or I meant the t and the cosine. Sorry. Man, today I've just been slurring over all my words. I don't know what's going on. Didn't really sleep much, but I guess that'll be a video for a different time. Anyways, this is a third order because of this dude. We could bring this guy to the 9th power. 3y times ln of t. Alright, that's fun. Because it's not being the y here is not being multiplied by another y, or a derivative of y, or there's no y being put in the argument of some transcendental function. That's not allowed. This guy is linear. Was this on the last slide? Oh, dude, it totally was. Well, you already know why. You already know why. Anyway, that's pretty simple. Some simple things that we're gonna be referring to constantly. So, pretty basic video.